Welcome. Today is February 23rd. Some of you may be joining us for the first time, and because of that, I'm going to try and make this more of a newbie broadcast. And I'm going to be going back to basics. Some of you may be joining us just to see what I have to say about the sun because you're wondering what happened yesterday. Let me assure you that it was impossible that it was any sort of attack. Um, our infrastructure is built in pockets so that it's isolated to pockets. So if, say, somebody's going after Google, that they're not going to be able to shut down uh, Microsoft and Bing. Okay, they can't get to all of the internet at one time. They can't get to every cell carrier at one time. And it would be nearly impossible for someone to take down the massive amounts of infrastructure simultaneously that they did yesterday. That is one culprit, and it is our sun. The good news is not World War III. Bad news is this is going to happen again. This was a wake-up call. This was a little bitty love tap to show us what the sun can do, and it was only a flare. This was nowhere near what it can do. And I'm going to sit down and explain the basics to you. So we're looking at our sun in a view of 193 angstroms. And for newbies, that means we look at our light in different filters that view it in different wavelengths of light or different light streams in different colors so that we can look at different details. In this one, we're looking at the flare right in here. And this is a sunspot in this area right here that's causing these flares. We have a coronal hole down here. And you're going to notice all these loopy things all over the place on the sun. Those are called filaments. Okay, so let's start with what is a filament. So a filament is an electrical circuit, like your house. It runs in one direction and it has to make a full circuit, just like your house. Around that circuit, all these little springy things are molecules like helium, nitrogen, oxygen. They all are in a plasma state. So they're gooey. They're not in a invisible airy state. They're in a gooey plasma state. They're like sticky stuff. And they're springing around that electrical circuit. And while it's electrical, it also has a magnetic component to it. And this magnetic component yesterday was positively charged. So it can have negative charge or it can have a positive charge. And sometimes the sunspots have both a negative and a positive charge in them. And that's when you know that a sunspot charge is or a sunspot can really erupt, is when you get the negative and the positive bumping up against each other. And in this case, this one is very positively charged. And we're on the northern hemisphere, and right now we have a negative charge. So positive, negative. Think of the bar magnets you did as a child in school. The north and the south do what? They attract. So we had a positive charge storm yesterday. We are negatively charged. It means that's going to attract whatever was shot out yesterday. So this is our sun. That's a filament. That's all how that works. Okay. Now let's talk of the difference between a CME, a flare, and what happens in the processes. So here is our filament right here. And it starts to stretch up off the sun like taffy. Has anybody pulled taffy candy before? Had taffy candy? It's stretchy. So this can stretch like taffy. And it stretches up off the sun, and it loses the ability to hold it to the surface of the sun. And then it kind of pulls, and it narrows down, and these narrow sides can bump each other. And when they bump each other, they create an explosion. And that's what we call a flare, when they bump each other. And it is an explosion of light, radiated, electromagnetically charged wind. Okay? So it is electromagnetically charged wind that has radiation to it. If it stops at a flare, it can reach Earth in as little as 8 minutes. Boom, it's here. If this continues to reach out, it flares and it reaches out and it flares again and it reaches out, and eventually those ends get so narrowed in that they twist and they break. Think of it like 10 atomic bombs, and it creates an explosion that strong, and it hurls everything in that top loop out toward Earth. And that is got helium, nitrogen, oxygen, all the periodic table. It's all coming toward Earth, and it's gooey particles, gooey goop, and it's all coming out toward Earth. It's dense. It's not air, it's got density to it. And it's coming, and that is what we call a coronal mass ejection, or CME. Now, a flare can happen without a CME. A CME can happen without a flare, or they can happen together. Fortunately for us, yesterday, it was just a flare. If it had been more than a flare, we really would have been in trouble. Once a CME happens, these ends snap back together. It will reconnect in what's called a magnetic reconnection, and recreate that loop, and it settles back down into the sun. So that is how that happens. As it reaches Earth, we have what's called a global electric circuit. And I'm sure some of you are kind of familiar with the idea that we have in our atmosphere electrical charge, because if we didn't have electrical charge, we wouldn't have lightning, right? And we've all seen lightning happen. We know it hits the ground, or rather, it moves up from the ground and meets the air, because our ground is electrically charged, electromagnetically charged as well. There's a whole dynamic charge here that has an electromagnetic charge moving all the way through Earth and our atmosphere. When all that stuff from space hits it, whether it's this flare and the winds from that flare, or whether it's a CME, it can excite the electrical magnetic, that global circuit, and it can amplify whatever's going on in our global circuit. Sometimes it excites it and it just causes auroras, and we all get to be fascinated by the beauty of nature. Sometimes it amplifies it and it takes that little bitty Category 3 Hurricane Ian and blows it up to a Category 5. Which is what happened to Category Ian, because the night before we had a solar storm that was supposed to be a little bitty storm, and it actually hit harder than we thought, and it was seen in Iowa, Des Moines, Iowa, and the next morning we got up to a Category 5 hurricane that they didn't predict. And by the way, the lightning in that storm, in that particular hurricane, was the worst lightning they had seen out of any hurricane ever. So it had been majorly affected by the agitation in the global circuit. Sometimes it just irritates the thunderstorms that are happening. And I have seen this happen, that we've had a solar storm, and I have seen spider lightning that has lasted thousands of miles. I mean, I couldn't see the ends of either lightning. I got up the next morning and the spider lightning was running the entire length of Michigan. So it can happen. It can do wild things. So I'm going to direct you to, well, actually, before I do that, I'm going to cover one last thing here real quick on the science. On Earth right now, we are doing, I want you to picture Earth with two poles through it. One is a physical pole, one is a magnetic pole. And our magnetic poles are bending toward each other, and they're going to cross somewhere over by Philippines, Australia, New Zealand. They're going to cross and flip. So instead of having a negative charge when we're done, the North is going to become a positive charge when we're done with this. But while we're undergoing this magnetic pole shift, our magnetosphere is getting very weak, and it's allowing all this radiation, all these space particles, all this electromagnetic energy to come lower and lower and lower into our atmosphere, and we're seeing things we've never seen before. And we don't know what to expect because no one was alive during the last magnetic reversal to know what was going to happen. It happened 400,000 years ago. So we're seeing mild, tiny aurora storms that shouldn't even be seen outside of Michigan, and we're seeing them in Texas, in Florida, New Mexico. Little KP5 storms are being seen in Florida. That means we're getting more into our atmosphere than what we think, and it's going to have more drastic effects than what we think. And that means the people that run our infrastructure are going to play catch up to how to protect themselves. Now, NOAA and NASA put out minute by minute reports every day, all day long, 365 days a year. Our electrical grids, our EMS services, our airlines, our train systems, our GPS systems, internet, cell phone servers, everybody watches these, and they all have alerts, and you can sign up for those alerts too. All those alerts, they get them all day long so that they, as soon as they get one, they can put in safety measures to protect the grids and or shut down any areas that might be at risk. Because they will shut down a power grid if they think it's going to get overwhelmed with electricity. They'll just shut the power grid down until the storm is over. So, that being said, sometimes it's just not what they expect. Sometimes it's bigger, sometimes it's smaller. So, first of all, start with this in your research. This is solarstorms.org, Space Weather Newspapers. Here is a list of all the solar storms that have happened since 1959, since they started tracking it, since they really sat up and paid attention, beginning with the Carrington event of 1959, which this was an X-class 45 storm, and it was daylight outside. People were sitting outside at midnight reading their papers. People went to work thinking it was dawn. Auroras were seen as far south as the Caribbean. I don't think there was anybody that didn't see the auroras off the storm. Telegraph operators were shocked. Some of them were badly hurt. Some telegraph poles burnt down. Some telegraph offices were set on fire. Some telegraph offices said they didn't have to charge up their system, that they could just send messages without doing anything. So some wild things happened with this storm. It was really a drastic storm, and it was the first storm that ever made people sit up and pay attention and went, whoa, we have something happening. But this goes through everything. There's some really interesting and wild stories here that cover everything from, it shut down when they put the transatlantic phone cable in, it burned up part of the phone cable. One storm made a British submarine disappear for several days because it just messed up the signal so bad they couldn't find it. It set off mines that were in a bay during the Vietnam War. That made all the mines explode because it electrified the mines. It messed up the radio signals during one of the world wars and for the Nazis, and it actually helped the Allied people the Allies win the World War. So it's had some significant effects. It has had effect on the military. So you will want to read this. You will want to understand just historically how it's affected us, and you'll want to begin to understand going forward how it can affect us in the future. Now, let's look at this particular storm, and I'm going to ask you to use your imaginations. You are the sun, and those little 3 big spikes are snow shovels. And you're going to picture a driveway, and the earth is on the other side of that driveway, and all that bumpy stuff you see here is snow. All this little bumpy stuff is snow. What it really is CMEs that are leaving particles of nitrogen, oxygen, that plasma gooey stuff. And some of it's moving right, left, down, up. It's moving in all different directions. It's moving fast. Some of it's moving slow. Some of it's really thick. Some of it's really thin. Some of it's got irradiated winds with it. It's very complicated snow. So we're going to picture it as very bumpy, ripply snow. So your first flare happened, and I don't know how fast that flare was, but I think it was a little slower flare and not quite as strong. I mean, it was strong, but it didn't have the effect of the second one, I don't think. And it started pushing all this stuff in front of it, and it might have slowed it down a little bit because it was pushing so much. Kind of like if you run into too much snow, it kind of slows you down a little bit. So it might have slowed you down a little bit. On the back side of this, you've got a big M-class flare, and this released a big M-class CME. And it's very long duration. It had a lot of stuff that it shot out into space, and some of it nicked Earth. Some of it was in between Earth. It was kind of off to the left, off to the right. We had 2 different storms go off, one to the left, one to the right, and they weren't directed right at Earth, but I think they were wide enough that they kind of grazed Earth, that the edges of the storm left snow in between Earth and the sun. Does that make sense? So you picture, it's not a straight shot. So you picture a cone. It moves out in a cone direction. So it spreads. So it left stuff in between Earth and sun too. So then we get that second flare, and that one was really moving. I can tell you that because we had phone service when I went to sleep. My daughter was up for a while, and all of a sudden she comes tearing in my room. Mom, what'd you do to the phone? It's not working. And I later, when I got service back, I looked and I went, oh, wow, we had a flare. And I looked at the timing, and it took about 8 minutes. This was moving. So it picked up everything that was in front of it and shoved it right at Earth. So I think you're looking at it picked up everything, pushed it right at Earth, and it had a bigger impact because it picked up everything in front of it. So it might not have been a big flare, but because it had a lot of plasma in front of it, it made it, amplified it, and it made it bigger. Following that, it took a while to come down from that flare. There was still a lot of light being released from that, but we didn't really have a large significant bit of flaring happen. There was some minor CMEs. They were all going off to the sides of us, not really hitting us. We had one M-class flare, and then we had an even bigger flare that did take out like YouTube, some gaming systems and stuff that didn't get hit earlier, that had to do some Band-Aid work to get things back online, that got hit with the third X-class flare. So that is what happened. That is why this could not have been a coordinated attack. The way it happened, how and what it took out would have been too complicated for hackers to do all at once. It's just not. I mean, the amount of work it would have been took to do just those particular things in just that way, it wouldn't have worked. And it would have taken many, 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 many hackers to do it. So this is another view of our sun. Will this keep up? Yes, this is going to be Earth basing and with us for about 5 days more. Fully capable of producing more activity and fully capable of producing a CME with it. And if it does produce a CME, it is fully capable of producing a kill shot. For those of you that are newbies, what is a kill shot? Scientists have been saying for probably close to 10 years, and we have, by the way, had kill shots, fortunately aimed directly away from us. Kill shots are something that the CME is above a KP45. The flare and regulated CME with it above a class 45 would be something that takes out our electro grids, cell phones, satellites, everything, and would tank everything for about 10 years. We literally would be back in the dark ages. And if you think I'm kidding you, just go do some research. Because the scientists have been saying this, it's not something new. The government just doesn't warn us about this because they don't want to cause a panic. But scientists have said it. It's fully acknowledged science. It is out there. It can happen. Fortunately, every kill shot storm we have had has gone away from us. There is a mechanism that kind of dampers the storms coming towards us. Don't fully understand what it is, but it kind of dampers what's coming at us. What can you do? Well, first let's go look at the sunspot. We have 3 new sunspots that were not there this morning. We had this sunspot. It is 3586. 3590 is our big one. It is beta gamma. what does that mean? Let's go look at this one. First, this is a alpha class. It means there's one sunspot. It does have positive and negative polarity. Negative is the red, positive is the blue. It has a 5% chance of producing a C, 1% chance at an X. 3590 is a beta gamma. This means it has multiple sunspots containing both positive and negative polarity within each sunspot, and it is an irregular shape. What does that mean? It means it does not mirror itself. It means I have a positive up here, I have a negative, a positive, and a negative, and a positive. It's not regular in its shape. It is down by half. So this front spot has shrunk in size by half since those flares released yesterday, which may be a good thing. It may be reorganizing. We are still at a 20% chance of an X-class flare, 90% chance at C-class flares. This is still a monster and definitely capable of producing something that could take out our power grids, take out our cell phones, take out a lot of things. $31.91 coming in is a alpha class. That means it's one sunspot right here, has negative and positive polarities within it. It is a little more capable of producing. And then we have 3292, and it is a beta class. This one is more regular in shape, and you'll notice that it kind of mirrors itself. It has a positive or a negative with positives in between and a negative. It is a mirrored shape. So this is a more regular shaped storm. And this one is a 20% chance at it really producing anything so far, but you know, it's developing. And then we have 93 that's going out. It's just developed overnight and it is in the baby phase. Look for this one to come back around because it's just developing. So this one should make the 27-day cycle. You will want to mark 27 days out from today to start watching for some of this stuff. Or no, 23. I'd start watching about 23 days from now for some of this stuff to rotate back around. So I would start watching about 23 days from now for this one. And I would look for this one to come back around. Now, for you newbies that don't know what I'm talking about, let me see if I can find. Well, let me go. We have what's called a 27-day cycle. Whatever's on the face of the sun, if it makes a cycle around the sun, will be back at us in 27 days. Right now, it looks really calm, and this is based on coronal hole activity. So it doesn't look like it's much. But that's because they cannot predict sunspots. They cannot predict a sunspot is going to do something when it gets around to the surface of the sun. You know, if I can know a sunspot's coming, but I can't predict that it's going to produce a flare when it gets here because they are unpredictable. This is predicted on coronal holes only. The dark patches on the sun. So we have coronal holes coming back around the 26th and then nothing on the 1st. But we do know that we do have a bunch of sunspots that we are predicting that will be back around the first part of the month. That we had a lot of sunspots that may be back around the first part of the month that may be very active if they come back around. So I would be looking and eyeballing the first part of the month for those sunspots to come back around. They are predicting we may see a spike here above a 5, nearly, or above a 4, possibly up to a 5 on February 25th. And probably in the daytime hours. Now, keep in mind that may or may not happen on schedule. They're right about 50% of the time. Can happen before, can happen afterwards. These things are very hard to predict because it's shoving 3D picture into a 2D model. And if you have a lot of things moving in different directions at different speeds, it's hard to tell when it's going to hit. So, also for newbies, if you go, this is the Space Weather Live page. And this is another resource that you can sign into that will give you all your resources. A lot of what you're seeing comes off this page. These are your Lascaux 2 and 3. Lascaux 2 is sitting off on our left-hand side. That is our incoming satellite. That peeks around the incoming limb and gives us a view. So Earth will be over here where that hand is. So anything coming directly at that hand will hit Earth. Lascaux 3 is right out between us and the sun. Anything that's coming right at that hand and coming all the way around that disk is going to hit Earth. And as you can see, it's lit up all the way around the disk. And here you can see a view of the last, I think it is 48 to 3 hours. And you can see, and what's over here is a, this is called Cactus, and it shows you a more granular, detailed image of what's coming off the sun, so you can see exactly the density and the amount of stuff coming off the sun. So yes, we do have some plasma coming at sun, and it can be really dense. I don't think it'll be too much of a problem though. So that is what we're at. Another page for all you that want to know is the Space Weather Enthusiast Dashboard. Ugh. This gives you, here is your flare classes. They don't have the big one on here because they're working off 16 and they didn't record the 18 flare on here. Here is your forecast for the next, this is done by KP. UTC is at this time 5 hours behind. Once we flip back to summer hours, it'll be 4 hours behind. So you subtract 4 hours. So if it says 2100 hours, you subtract 4. So if it says 0, you subtract 4, it's 8 o'clock. So at 8 o'clock, expect a KP3. We have some views of our sun here. We have our Lascaux 3. All right, an important thing of note here for newbies. You see how this is broken and it's jogging up and down right here? This is one of the things I watch for to know that I have a magnetic load going on. It's hitting our satellites. There's magneticism going on. And I know that I'm going to have an onset of auroras. It doesn't tell me what charge it's going to be. It just tells me I'm having an onset happening. That's when the storm is hitting the satellites. Up here, it tells you whether it's positive or negative. Remember, we need the positive to be seen, or the negative to be seen. Right here is your density. The higher it goes, the denser it is, the better the picture. This is our wind speed. The faster it goes, the more colors you will see, the different colors you will see. This is what's called an emerald spiral. So the top thing measures density of plasma and what's going to hit Earth. And you can see we've got a minor amount of plasma that's hitting Earth. But you can also see, and this, then down here we measure the radiated winds that's going to hit Earth, and you can see we're going to get a major push here from the X-class flares and the radiated winds coming. And this is the coronal hole stream coming in too. So we have a coronal hole stream that's going to hit on the 5th, and that's going to elevate our winds for 24 hours. So we have a double whammy here that may elevate things just a little bit. Down here we have the GOES proton flux. This is our magnometers. That's measuring when we have a peak in magnetic energy. And you can kind of see where it starts. It doesn't follow the KP. It's off from the KP. See how it goes? It's going up here and goes down. And then it elevates. And it stays elevated here, but the magnometer is going down. So we have more going on in here than what is going on up here. Now, this here is our radio signal disruption. That is telling us where the global radio absorption is predicted. This is the frequencies that are getting affected. So this is the radio frequencies that are being absorbed on the face of the planet. And you can see right now we're in the daylight hours and we're having some minor radio propagation problems right now on the surface of the sun. And this tells you the total electron disruption in the circuit here, and we're right down in good levels. We don't have a lot of ionosphere disruption up here. So these are all tools that you can tell, that you can go to the next time power goes out, or say your cell phone goes out and you don't know what's going on. Go look at these tools if you have internet before you jump to the conclusion that it's an attack. Because if you see disruptions on these, then you know it's not an attack. Okay? These are things that you can look. Now, I'm going to back this out. I'm going to try and back this out. You can see right here that we're having the strongest peak so far down here in solar 25. We're already stronger than we were last cycle, and we're on track to be bigger than we were in 2000. We could have another 1960s. Possibility. We don't know. Scientists thought we would be in a grand minimum right now, and this is already taking off to be bigger than they expected. So we don't know what's going to happen with this cycle. We're just starting this cycle. It could be way bigger. It could go up and be a double peak like last time. That lasted a while. We're going to wait and see what happens. But you can see we've had bigger storms, big peaks, and we've survived them. You will survive what's going to happen. It's not the end of the world. Can we have disruptions? Can we have issues? Yes, but we will get through it. It's not the end of the world. It's not World War III. It's a minor bump in the road. What can you do to prepare yourself? Well, Do like you do for anything else. Prepare a go bag, just like you would for a major tornado, earthquake, hurricane, anything else. Prepare a go bag. Only this time, put it in uh, a metal trash can, and with metal tape around any opening in the trash can. Put in flashlights with batteries, anything electrical that you want to keep and be able to use after an event. Put it in what's called a Faraday cage, and make a Faraday cage and use that as your go bag. Make sure you have water. Make sure you have some sort of heat source that you can use that is not electricity dependent. Look and see what you make sure you've got food in your house that you can cook without being dependent on electricity. That's basics of what you can do. And this is not a bad idea just to do a practice on, because in the event of a war, we know that China and Russia and all these places want to attack our infrastructure. It's not a bad idea to do some practice to learn to live without the infrastructure. To look at these things and say, how do I live without them? Because it just makes us stronger if we can do without them. It just makes us stronger if we can function the old ways and operate and know exactly what we need to do without them. It makes us less vulnerable. So it's just a basic good common sense to set up a practice and figure it out. It makes you more prepared, and preparation is everything. Will it happen again? More than likely. The sun will cause problems again. Could cause problems for 3 days like it did in Canada and took out the power grid for 3 days. Could take out the cell phones for a couple hours. Could take out internet for a week. It could take out things for 10 years. We don't know. We don't know what and when and how things are going to happen. Nobody's lived through a magnetic pole reversal. But the best thing you can do is prepare yourself to live without electronic things. To learn to protect yourselves without having to depend on electronics. How do I heat? How do I eat? How do I get water? That's what you need to know. How do I get safe drinking water? How do I eat? How do I function? You have to have water, you have to eat, you have to have heat. Anything else is, gravy. Other than that, don't panic. It's all natural. We'll live through it. The earth has lived through it before. It's still here. We're still here. It'll happen again. We'll make it through it. Sit back and enjoy the auroras. Have a good show. By the way, for newbies that don't know it, if you live near Traverse City, when we have a good KP value above KP5, I do call for lights out at the Greek Orthodox Church up in Williamsburg. And that functions as a dark sky park that you can go up and view the auroras at. Please park on the southwest side of the building. Leave the northwest parking lot closest to the building for handicapped people, and leave the northeast parking lot open so people have a place to stand. And there's places in the back that you can stand. It is family friendly, and there is handicapped areas there that are accessible for people that have disabilities that want to see the auroras. Where other than that, there's lots of other areas around the area. There is the Platte River that is a good area. Esh Beach is a good area to go to see auroras. Good Harbor, you can see auroras at Woolsey, Old Mission Peninsula, up at the lighthouse. It gets a bit overcrowded, but you can see them there. There are some limited areas up in Elk Rapids that you can see auroras at. You can see auroras up at Charlevoix Beach. I advise against going to Mackinac Dark Sky Park because they have a habit of getting overcrowded and closing that park down. But you can go up to Mackinac and go around Mackinac Lighthouse and over by the Coast Guard ship and get a beautiful view of the auroras over there. And Paradise also is a beautiful place to go up and see the auroras up there at the Whitefish Point Lighthouse. And the Whitefish Bay boat dock there is another place you could go to see auroras. So there's lots and lots of areas, public areas that you can go to see auroras and enjoy yourselves. So enjoy. Don't all crowd into one place. Next month will probably be our better month. I do then look toward April, May. And then usually the end of August through the middle of October, we get a generally really big show in there. So those will be your best times. You can tune into our channel and we try to keep you updated. If I am quiet, there is nothing going on. If I am quiet and that there's auroras, but I'm quiet, it's because there will be absolutely no chance you're going to see anything due to either clouds or smoke. And I am one of the few channels that do give you smoke reports and tell you if smoke is going to be a problem or not. And that historically has been a problem in the Great Lakes when we have large Canadian or California wildfires. We have had smoke drift to where we can't see anything. So I will leave you there. If you like and enjoy what I've explained or want to see the auroras on a regular basis, please like and subscribe, share our channel. The more we do, the more I can build our channel up and do better video content, do more often, more things like doing cell phone training videos or camera training videos, and actually be able to film an actual class, which is on the agenda to do at some point. So I'm going to leave it there. Everybody have a good day and don't panic. Not World War III, just our sun letting us know that we need to be prepared. We need to not forget he's there and forget that, it has a major impact on our world and that we need to not be so complacent.